Okay. Now the 2 is the mass difference. According to that, the value होनी चाहिए थी 20, but according to the mass spectrometer it measure 18. The 2 is the mass defect. Now what is the mass defect? Mass defect is a concept of a binding energy. No question is raised, what is the binding energy? The energy is required. वो जो 2 difference है वो कहां पे यूज हुआ? टू सेपरेट द न्यूक्लियन फ्रॉम द न्यूक्लियस. प्रोटॉन्स एंड न्यूट्रॉन्स को सेपरेट करने के लिए जो एनर्जी रिक्वायर्ड है, दिस वन इज द बाइंडिंग एनर्जी, दिस वन इज द मास डिफेक्ट. I repeat, okay, according to the theory, the nucleus is made up of neutrons and protons. If I talk about the mass is proton 10 and neutron is 10, the value is 20. Mass value क्या आएगी? 20. But when okay practically perform this thing with the help of a mass spectrometer, so this theory is a wrong. Okay, the value of mass is equal to 18 according to the experiment, according to the mass spectrometer. Now question is raised, where is 2? To 2 is the mass defect. Experimentally always mass of nucleus is less than the sum of neutrons and protons. Okay, so 2 is the mass defect. Okay, the 2 mass, okay, mass difference, where 2 is a mass difference. Okay, this is the binding energy, means this difference is required to separate the nucleons from the nucleus. This concept is called binding energy. Okay, I hope you understand what is the binding energy. From this, okay, from this we will, you know, we had already started, and till that point I hope you understand what is the definition, okay, definition and concept of a binding energy. Okay, mass defect be denoted by delta m. Okay, if I talk about the mathematically formula of a mass defect, delta m is equal to n mn plus zmp plus minus m. Now where the n is number of neutrons present in the atom and mn mass of the neutron, plus number of protons present in the atom, into means multiply by mass of a proton, and minus m. M is the mass of a nucleus. Okay, so this formula we used for finding the mass defect. ये कितना mass defect है? Okay, उतना वो किसके इक्वल होगा? बाइंडिंग एनर्जी. When you find the binding energy, delta m multiply, it is the constant value 933.76 mega electra volt. Means when you find the mass defect, multiply this constant term, so you find the binding energy. Okay, binding energy is required to the separate of nucleons from the nucleus. I had already discussed with you. So binding energy per nucleon is equal to binding energy upon number of nucleon. Means binding energy per nucleon, you find this formula. Okay, so this one is the binding energy concept. Now the graphically representation of binding energy versus atomic mass, most important concept in this chapter. If examiner put the question from this chapter, so he or she choose this topic, the binding, okay, graphically representation with mass defect and atomic mass. I had already discussed in the starting of the this chapter. Okay, in 2023 the question 3-mark question is, okay, that graphically representation, which element have maximum binding energy, which have lowest energy. Okay, this one is the graphically representation of binding energy per nucleon with mass number. Okay, in y-axis, if I talk about, okay, we take binding energy per nucleon 2, 4, 6, 8, 10 up to so on. And in x-axis, we take a mass number, okay, 0, 50, 100, 150, 200, 250. Okay, this one is the generally diagram, but when you draw, okay, it's a difference is the same. Okay, इसका difference same होना चाहिए, not आगे, okay, it is a mathematically diagram, just okay, focus on कि which element have a maximum binding energy, which have a less minimum binding energy. Okay, generally focus on this. Okay, it's a most important point, okay, for your focusing, and it is also most important point, okay, from this diagram. Now you can check from okay, when the value is 0 to okay 0 to 50, or we can say 0 to 30, it is the hydrogen, okay, atoms and helium atoms here, and at approximately 5 point something lithium we take, and 7 point something we can take carbon 12, okay, here the nitrogen 14, and at that point oxygen 16, and at that 18 oxygen, and this one is the okay 32, and it is the most important thing is here, okay, iron at iron. Okay, so then 56 iron has maximum binding energy. You can check from the diagram. इसी को मैंने high पे रखा है. If I talk about is the maximum binding energy, means we can say the value of A is greater than 30, and less than 170. Okay, greater than 30 and less than 170. The binding energy per nucleon is small. Okay, now you can check from the diagram 56 iron has a maximum binding energy, and now you can check the value of A. Okay, A is the atomic mass. Okay, if the value of atomic mass is less than 30 and greater than 170, now you can check from the graph the value of binding energy per nucleon is small. Okay, if I talk about the 170 above the, then you can check the uranium is here, means if the value is less than 30, okay, less than 30, under the 0 to 30, the value of binding energy per nucleon is less. So this one is the graphically representation. Okay, binding energy per nucleon is per nucleon atomic mass versus atomic mass. This graphically representation is also called a binding energy per nucleon mass curve. Okay, curve के साथ इसको introduce किया जाता है, binding energy curve. Okay, in your NCERT and in your syllabus also. Okay, so we can also say कि graphically representation. Okay, I had already these things discussed कि iron has a maximum binding energy and less than the 30, mass number less than the 30 and greater than the 170, binding energy per nucleon is small. And from this curve we will introduce these things, because okay, in this case binding energy curve, okay, energy is a release. Okay, energy is a release because there are the two processes and two things are here, nuclear fission and nuclear fusion. Okay, if I talk about the nuclear fission, so have in this nuclear fission, heavy nucleus is breakdown into lighter nuclei. So then energy is released. And in a nuclear fusion, two lighter nuclei combine with each other, or we can say fuse with each other, it's converted into heavy or heavier nucleus. Okay, so this one, these two terms introduced from the binding energy curve. Okay, so any doubt you can ask, okay, through the text on a team, okay, you can text on a team anytime on my id. I will, okay, reply when I free. Okay, any doubt regarding atoms, nuclei and semiconductor? Okay, your next chapter is the semiconductor. Till that, okay, nucleus is completed, and till that chapter, okay, the syllabus is completed of your PA1. Okay, and numerically things I will discuss when I come, okay, in the offline class. In this atom and nuclei, there one is the only a one numerical part, one or two numerical part is here. Okay, so we will continue when I offline. Okay, I will come to school, okay, in an offline class, but focus on this online, okay, sessions. If any doubt till that point, you can ask anytime on team. Thank you so much. Okay, we will continue in the next chapter. Okay, the chapter is the semiconductor.